Hello everyone. First, let me introduce myself. My name is Yovinta Intina Salsabila, second year exchange student from Indonesia in Department of Biology, Faculty of Science, Chulalongkorn University. I'm from Primate Research Unit Laboratory, working under my advisor that is Professor Dr. Sucina Malai. Today, I would like to present my seminar about wildfire smoke impacts, activity, and energetic of wild Bornean orangutans. As we know, orangutans are one of Indonesia's treasures, considering that Indonesia has really a huge number for the species witnessed. Indonesia is an archipelago country located in Southeast Asia, lying between the Indian Ocean and the Pacific Ocean. It is located in a strategic location astride, or along major sea lines connecting East Asia, South Asia, and Oceania. It is the world's largest island country. Indonesia is also well known for its mega biodiversity. For example, we have around 12% of the world's mammals, including the primates. You can find 59 species of non-human primates in Indonesia, while in Thailand you can only find 17 species of non-human primates. Orangutan is one of the non-human primates inhabit Indonesia, and it is the only one great ape inhabit Asia. There are three species of orangutan. The first one is Sumatran orangutan, Pongo inhabit top of Sumatra Island. The second one is Tapanuli orangutan, Pongo tapanmensis, also inhabits Sumatra Island, and Bornean orangutan, or Pongo pygmaeus, inhabit Kalimantan or Borneo Island. Unfortunately, orangutan must dealing with the significantly decrease of their number each year due to the illegally hunting and habitat loss, make IUCN has to categorize these species into critically endangered species. Orangutan themselves is solitary arboreal animal, which means they tend to live individually and spend more time for living and moving in trees. They survive on a diet of fruits, leaves, also small animal prey. Orangutan is sexually dimorphic. In this case, males often have large fluffy cheek pads that called by flanged. There are some difference between the flanged male and the non-flanged male, other than their fluffy cheek. The flanged male has high level of testosterone, so that means they are fully ready for mating. They will start seeking for females and can roaming around up until 20 km per day. These males will be often on the ground too. So this fascinating creature unfortunately have become critically endangered species because of habitat loss such as deforestation and some serious wildfire. In 2015, Indonesia was struggling to cope up with the most severe wildfire and smoke pollution after Indonesia's fire that occurred in 1997 exacerbated by drought conditions produced by strong El Nino weather system. Yet, there is a lack of research into adverse effects on wildlife. Here, I also have a video that shows that condition in Kalimantan during the fire season. Well, let's enjoy the video.
In our last story this hour, humans are not the only ones suffering from the haze hitting this region.
At a central Kalimantan rehabilitation center, dozens of orangutans are choking as forest fires burn on the islands of Sumatra and Borneo.
Caretakers detected breathing problems in some of their orangutans and have started moving them into facilities with cleaner air for monitoring.
Fires have ripped through the forests and peatlands of Indonesia since January, unleashing choking haze across Southeast Asia and sending air quality to dangerous levels.
And conditions this year have been the worst since 2015.
As you can see the video, the conditions in Kalimantan during the fire are very worse, and the orangutan health is critical. So, in this study, the problem is to know how is the impact of wildfire smoke to orangutans' daily activity and energy budget. Orangutan were chosen because of its role as an indicator species whose health and behavioral signal environment quality. And the objective of this study is to show that the smoke caused by the wildfire can negatively affect the orangutans. And for the study site, the study is conducted at the Tuanan Orangutan Research Station, Central Kalimantan, Indonesia. So this is Indonesia, and the area that shown by red square is Kalimantan Island. And then this is the Central Kalimantan where the study is located. So before we go to the methodology, I will show you a short glimpse about what actually happened in Central Kalimantan several years ago. Started in 1996, there was a mega rice project that resulted in the construction of more than 4,500 kilometers of drainage and irrigation channels. Massive deforestation has also been done to open up space for the project. The project did not succeed because the nutrient-poor peat soils were ultimately unforgiving. Next year, after a year of drought induced by a strong El Nino, fires started burning underground through the peat soil itself, contributing to a loss of 72% of peatland forest in the following 9 years and leaving much of the peatland deeply degraded. Peat is a major store of carbon. If broken down and burned, it contributes to CO2 emissions, a source of global warming, and can cause fire as well. The government has therefore abandoned the project, but the drying peat is vulnerable to fires which continue to break out on a massive scale. And finally, in 2015, peat fire exhibited the most severe fire activity and smoke pollution recorded since NASA's Earth Observing Satellite system began observation in the early 2000s. Here is for the methodology. The data were collected between March 2015 and January 2016 and were divided into 3 periods: pre-smoke, smoke, and post-smoke. Then, for the subject animal is 4 adult flanged males. For the data collection, we can separate it into 2 main groups, physical data and biological data. The physical data consists of air quality and fire activity. Air quality was assessed via concentration of PM10 collected daily by the BMKG, or Meteorology, Climatology and Geophysics Council in Palangkaraya, located approximately 55 km west of Tuanan. And we collect number of fire hotspots in Central Kalimantan from the National Fire Information for Resource Management System. The last one is biological data, which consists of 3 sub-data: behavior data, energy budget data, and ecological data. For this data, I will explain them further in the next slide. First is the biological data. Active period is the duration from the first activity point after leaving the nest in the morning until resting in the nest for the evening. Rest time is calculated from the proportion of instantaneous samples when resting during active period. Travel time is calculated from the proportion of instantaneous samples when traveling during active period. Travel distance is calculated from path length referring to GPS with 10-minute interval. And the last one is energy intake, which is calculated from the species, part, and richness of food items or feeding board. Is the behavior data, is energy budget data, I'm so sorry. And here we want to know whether the animals are suffering ketosis or not. To determine it, we collected urine samples. Samples were collected by positioning a plastic bag under urinating animals or by immediately pipetting urine from the lips or ground. Then the urine samples were tested using chemstrip test strip to test for ketones as soon as possible. And the last one is the ecological data. To document ecological habitat change, we calculated the monthly food availability index as the number of trees bearing fruit divided by the total numbers of trees sampled. The trees that are monitored is covering 2.3 hectares of foraging area for the orangutans. The statistical analysis that is used in the study is linear mixed model, or LMM. So we divided the study period into 2 phases. The first one is immediate effect, when we compare the data between pre-smoke and during smoke. And the second one is persistent effects when we compare the data between post-smoke and during smoke period. So later, I will use these two terms frequently for my presentation, the immediate effects and the persistent effects. Okay, so this figure shows the PM10 level at Palangkaraya. This red dashed line represents the Environmental Protection Agency unhealthy limit. So, if the PM10 beyond this level, that means it is dangerous enough for health and environment. Then the blue one represents the PM10 after lighting a cigarette. The solid black one represents the maximum point of PM10, meanwhile the dashed black represents the mean value of PM10. Next, we have the number of fire hotspots data during smoke period throughout August until October. The gray line represents number of fire at Palangkaraya, while the black line represents number of fire at Tuanan. From here, we can see the correlation between the first data and the second data. Palangkaraya reached its highest number of fire hotspots in September and continue until October, so that can explain why PM10 level at Palangkaraya suddenly increasing significantly in September and reached its maximum in October. But how about at Tuanan? We don't have any data in Tuanan. Although there is no PM10 level data at Tuanan here, we can assume that it should be even worse rather than at Palangkaraya because Tuanan has higher number of fire hotspots. And of course, increasing of fire hotspots causes the increasing of smoke too. The next one. This picture shows the results of each indicator for behavior data. Then I will give this blue sign to show that the data is significantly increased. Also, I will give the red sign to show that the data is significantly decreased. In previous slide, I have already mentioned about the intermediate and the persistent effect, right? But let me remind you again. So the intermediate effect is used when we compare the data between pre-smoke and during smoke, and the persistent effect is used when we compare the data between post-smoke and during smoke period. From this data, the intermediate effect for active period is remain the same, but is increased in rest time while decreased in both of travel time and travel distance. So in here, we can say that orangutan is resting more and less active. Then we can move to the persistent effect. The persistent effect for active period is still the same. In rest time is still increased and still decreased in both of travel time and travel distance. So we can say with the persistent effect point of view that orangutans still resting more and so they were less active too. Now we can summary from the intermediate and persistent effect that orangutan rest more and less active during smoke and post-smoke. Next picture are the results of energy budgets, including energy intake and ketones level. Again, the blue signs show that the data is significantly increased. Same here, we will use the intermediate effect and persistent effect to comparing data. The intermediate effect for energy intake is same, so with the ketones level. From here, we can say that orangutans eat as usual. No problem occur with their eat, and their fats are not burned. Next, the persistent effect for energy intake is the energy intake increase, so with the ketones level is also increasing. From this information, we can say that orangutans eat more, but they also burn more fat. When there are any fats are burned, this event is called ketosis and will produce ketone. So, if there is a ketone, the fat is burning, meaning that animal get more energy. In general, ketosis or fat burning happen when there is a lack of energy intake, but these results show that ketosis is detected at smoke period when the energy intake is unchanged, and when ketosis is increased post-smoke, the energy intake is also increasing instead of decreased. So, the orangutan eat more and burn more fat, but then this indicates that the orangutan still need more energy. And in here, These are the figures that show us the data about the correlation between food availability index and sample with ketones. To make it easier, I want to explain it step by step. First, it starts with the pre-smoke period. We can see that the level of FAI is low, so that means that there is not much food there, but in the other side there was no ketones detected. So in pre-smoke period is low FAI and no ketones. Then we will go to the next step, that is the smoke period. In this period, the level of FAI is very high and it starts to show ketones level there. And the last step is the post-smoke period. In this period start to decrease, but somehow the ketones is still occur and become more higher. Okay, then I will show you the whole step. So the FAI was high during August until October because of the fruit blooming season, although there is the smoke period, and the FAI was low during pre and post-smoke. However, the ketones was detected at smoke and post-smoke period, and importantly, the ketone was not detected at pre-smoke even though the FAI level was low. Therefore, presence of ketones was not due to reducing of caloric consumption. Okay, so this information is not included in the paper, but I want to explain it how the ketones is produced by the body, because I already mentioned many of ketones in the previous slide. So the ketones bodies, named acetoacetate, acetone, and 3-hydroxybutyrate, are produced during an extensive fatty acid oxidation. They are the products of acetyl-acetyl-CoA and acetyl-CoA condensation. That limiting step of ketogenesis is the formation of 3-hydroxy-3-methylglutaroid-CoA or HMG-CoA and is catalyzed by mitochondrial HMG-CoA synthesis. Utilization of ketone bodies as a source of energy, 3-oxoacetyl-CoA thiolase and beta-HT dehydrogenase are necessary. For degradation, succinyl-CoA, acetoacetate-CoA transferase, also known as 3-oxoacid-CoA transferase, is necessary. All of these enzymes are present in peripheral tissue at various levels, but succinyl-CoA acetoacetate-CoA transferase is absent in the liver. So, a previous study also said that the exposure to high level of PM10 in humans can induce chronic inflammatory response, adversely affecting the cardiopulmonary. The other study also said that inflammatory response increased energy expenditure. Previous study in Singapore said that the ecological community acoustic activity significantly reduced during the 2015 Indonesian haze, and unfortunately the only partial recovery 16 weeks after the smoke. In here we can say that they somehow get the chronic effect, and the chronic effect is occurred as well. So after all about the dangers of PM10 for any living organism, how about the PM2.5 in Thailand? The PM2.5 has more smaller size than the PM10, and logically, this particle can more easily pass into our body through the respiratory system, and it will be more harmful, especially when the concentration is very high. The suggestion for the future study is that the further studies for the long-term effects is necessary, and the future studies should include non-adult, fetus and infants, and also additional physiological indicators health. But, in my opinion, we must also include the elderly as well, because they are also vulnerable and must get the huge impact for their health too from the smoke. Finally, the conclusion of this paper is the wildfire smoke can negatively affect orangutans' daily activity and energy budget, which lasts longer even after the smoke. If it can impact the apes so badly, so do with other creatures. including humans. So I think that's enough for my presentation. And here I want to give my acknowledgement for Achan Cinda and my senior, that is Mr. Taraton Finanza, also the PRU lab member as well, for the valuable and constructive suggestion during the planning and development of my preparation for the seminar. And if you have any question regarding my presentation, please don't hesitate to ask me some question in the comment section. Thank you for your attention and have a good day, and please stay safe everyone.